all, I would like to introduce myself, Chadhav Madhav Sopanrao, an assistant professor, Department of Chemistry, Shivaji College, Parvani. My educational qualification is MSc Organic Chemistry, NET, SET, PED. I have completed my graduation as well as post-graduation in Yashwant Mahavidyalaya, Nanded. I have just registered for PhD in November 2017. In this year, I am going to teach the physical chemistry, which paper number is 7. Now we are going to learn the thermodynamics first. In thermodynamics, there are two words. One is the thermo and another is the dynamics. Thermo means heat and dynamics means flow. So flow of heat is nothing but the thermodynamics. Heat is one of the form of energy, and we know the energy is the capacity to do the work. There are several forms or types of energy such as kinetic energy, potential energy, electrical energy, light energy, chemical energy. Heat energy is also known as a thermal energy. Energy can be interconvertible, means energy changes from one form to another form. Whenever a system changes from one state to another state, there is some change in energy, and that change in energy in the form of heat, work, light, etc. Energy, the unit of energy in CGS system is erg, and in SI system the unit of energy is joule. So thermodynamics is the branch of science which deals with energy changes in physical as well as chemical processes. So in this thermodynamics we have to learn the basic concepts, first law and second law of thermodynamics, and their relevant application in physical as well as chemical. Before going to start our syllabus, we should know the basic terms involved in the thermodynamics. First term is the system, the part of universe which is under thermodynamic study or thermodynamic observation is called as the system. Thermodynamic study or thermodynamic observation is the study of energy changes. For example, hot water in beaker or hot water in a vessel. Hot water is system for us because we are going to observation of that heat flow. So hot water present in that beaker is system for us. Another best example is the hot tea present in the cup. So hot tea is the system for us. Hot coffee in the cup is another good example of system because we are going to observation of that coffee. Another example, cold water in vessel or cold water in beaker. Here also we are going to under the observation of energies changes. Okay, so we have to see the another term, that is the surroundings. Surroundings is nothing but the remaining part other than the system is known as surroundings. For example, hot water present in the beaker, the remaining part other than that hot water is surrounding for us. Another example, hot cup or hot tea present in the cup, remaining part other than that hot tea is surrounding for us. Next term, that is the universe. Universe The system and surroundings are collectively known as universe. So hot water present in the beaker and remaining part other than hot water is universe. Another example, hot tea present in the cup and remaining part other than that hot tea is universe. Boundary, an imaginary or real line which separates the system and surroundings, is known as boundary. We have to see another basic concepts, that is the types of system. First types of system is open system, a system which can exchange matter as well as energy with the surroundings is known as open system. Here matter and energy changes with their surroundings. For example, hot water in beaker. Hot water present in beaker, there will be change in energy as well as change in that matter. In beaker, there is change in energy as well as change in that matter takes place. Another type of system is closed system, a system which can exchange only energy but not the matter with its surroundings is known as a closed system. For example, hot water present in a closed beaker. In that closed beaker, there is only change in energy, but there will be no change in the matter. Means matter or mass remains constant in closed system. Another type of system is an isolated system, a system which can neither exchanges matter nor the energy with its surrounding is known as a isolated system. For example, thermoflask. In that thermoflask, hot water remains hot and cold water remains cold because there will be no change in matter as well as there will be no change in energy takes place. Means energy as well as matter remains constant in an isolated system. Now we have to see thermodynamic processes. First type of process is the adiabatic process, the process in which a system does not exchange heat energy with the surroundings, means there will be no heat leaves or no heat enters from the system. In this process, delta Q is equals to 0. In this system, temperature of the system changes. Temperature of system will decrease in adiabatic expansion of an ideal gas, whereas the temperature of system will be increased in adiabatic compression of an ideal gas. We have to see in our later lectures. Now we have to see the next process, that is the isothermal process, the process in which temperature of the system remains constant, means temperature doesn't changes. That's why delta T is equals to 0 in an isothermal process. So in this process, heat is either supplied to the system or removed from the system. Such type of processes are carried out in thermostats. Examples of the isothermal processes are melting, freezing, evaporating, sublimation. We know melting is the process of conversion of solid substance into the liquid substance. Freezing is the process of conversion of liquid into solid substances. Evaporating is the process in which liquid substance is converted into the gaseous state or gaseous substances. Sublimation is the process in which solid substance gets converted into gaseous substances without converting it into the solid without converting it into the liquid state. Isobaric process, the process in which pressure of the system remains constant. So in this isobaric process, delta P is equals to 0. For example, expansion of gas in open system. In this expansion of gas, pressure of the system remains constant. Next type of process is the isochoric process, the process in which volume of the system remains constant, in which delta V is equals to 0. Reversible process, the process in which driving force is infinitesimally or very small greater than the opposing force. Here, driving force is the force exerted by the system and opposing force is the force exerted by that system, exerted on that surrounding. So in this process, driving force is infinitesimally greater than the opposing force, means driving force is similar to the opposing force. So in this process, direction can be reversed. So the process in which direction can be reversed by change in variable like temperature, pressure, volume. So in this process, system remains in equilibrium with the surroundings because driving force is nearly same to the opposing force. Next type of the process is the irreversible process. The process in which driving force is much greater than the opposing force. Example, all the natural processes are irreversible processes. For example, expansion of gas from higher pressure region to the lower pressure region